Hi viewers, welcome to LMS. Today we are going to see about sliding mode controller based PSO MPPT algorithm for solar system. This is the model used to for testing the sliding mode controller based PSO MPPT algorithm. This model consists of 250 watts PV panel. The open circuit voltage of this panel is 37.3 volt. The voltage at maximum power point is 30.7 volt. Short circuit current is 8.66 amps and current at maximum power point is 8.15 amps. This is a PV IV characteristics of a 250 watts PV panel for changing irradiation condition. Here we are fixing the irradiation at 1000 watts per meter square, 800, 600 and 400. Here you can see the peak point of PV panel for different irradiation condition. For 1000 watts per meter square, the maximum power is around 250.2 watts. For 800, the maximum power is 199.9 watts. For 600, the maximum power is 149.6 watts. For 400, the maximum power is 98.9. This is a peak power of the PV panel for different irradiation conditions. This peak power should be tracked by the sliding mode controller based PSO MPPT algorithm. The load, this is a load connected here. A load is connected to the PV panel via boost converter. This is boost converter is connected between solar PV panel and the load. This boost converter going to act as a power modulator in order to extract the maximum power from the PV panel. The boost converter IGBT switch going to be controlled by means of a sliding mode controller based PSO MPPT. The PSO MPPT receiving two inputs. One is PV voltage and the PV current. This one nothing but the particle swarm optimization based MPPT. This MPPT will generate the reference voltage here. Based upon VPV and IPV, it generating reference voltage. So this reference voltage nothing but the reference voltage at the peak power or reference voltage at the maximum power point for the different irradiation condition. This reference voltage or reference maximum power voltage going to be compared with the actual PV voltage here. The reference voltage and the actual PV voltage compared here. And then this is nothing but sliding mode controller. The sliding mode controller receiving two inputs. One is error, another one is a rate of change of error. Based upon this error and rate of change of error, the sliding mode control will be generate the control signal for this hysteresis controller. So this hysteresis controller process this control input from the sliding mode controller and it will be generate the pulse for this IGBT in order to extract the maximum power from the PV panel. This power will be supplied to this load, DC load. Here we are going to test the model with the two set of condition. First I am going to test the model with the change in irradiation condition with the constant load. I am going to use constant load. The load is constant. And then here I am going to vary the irradiation. I am going to vary the irradiation from 1000, 800, 600, 400 for every 0.2 seconds. And I am going to analyze the result of PV power, load power, PV voltage, load voltage, PV current and the load current. So this is first set of testing conditions. The second set, I am going to make the irradiation temperature constant and I am going to change the load is variable. So I am going to change the load during that simulation process. Initially this load will be connected to the system. After 0.3 seconds I am going to add this load. During that load, sudden load changing condition, we have to check the maximum power extraction from the PV panel because of this sliding mode control based PSO. These two conditions we are going to analyze in this system. First I am going to test the first condition. That means here I am going to change the irradiation for every 0.2 seconds from 1800, 600, 400 and I am going to make the load is constant and then I am going to check the result of PV, voltage, current and power. I am going to simulate this model. Here you can see that this PV voltage is maintained around 30.7 volt. Initially it's around 32. After that it is to 30 volt. Now after some time 0.6 is goes to 29 volt. So this is a boost converter voltage. Because of change in irradiation, we need to extract the maximum power from the PV panel. Then the voltage of the load are going to be changed according with irradiation. And also you can see the PV current. This is a PV current for the different irradiation for 1000, 800, 600 and 400. This is a boost converter current for the 1000, 800, 600, 400 watts per meters. So here you can see the PV power for 1000 is around 250 watts, for 800 is around 199, for 600 is around 149, and for 400 is around 98. Let me check the result with the theoretical one. Here you can see that for 1000 watts, the maximum power is theoretically is 250.2. Here you can see that here we are getting maximum of around 250 watts. For 800 watts is the maximum power is around 200 watts. So here you can see that we are getting 200 watts for 800 watts per meter square. For 600, the maximum power is 150. So here you can see that we are getting 150 watts per watts for a 600 watts per meter square. For 400, the maximum power is around 99. So here also we can see that we are getting the maximum power from the PV panel. For a particular condition, the sliding mode controller based PSO MPPT, they extracting the maximum power from the PV panel. Next, I'm going to check the second test condition. That means I'm going to make the irradiation is constant, and then I'm going to change the load after 0.3 seconds. That means initially at up to 0.3 seconds this load will be connected. After 0.3 seconds this load will be connected with the system. So you have to check the results of the voltage and load voltage, PV current, load current, PV power and the load power in order to test the sliding mode controller based PS. Now I'm going to simulate the model. Here you can see that we are getting maximum power 250 watts. The time of 0.3 seconds, you can see here the load will be changed in the system. The load is added in the system. Because of that, we can see that the converter current, that means load current changed from nearly 3 amps to 3.5 amps. And here you can see that during that sudden load changing condition also, you can see that the maximum power is extracted from the PV panel by means of sliding mode controller based PSMP. This is working of the sliding mode control based PSMPPT for solar PV system. Thanks for watching your videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.